Okay, so hello everybody. Can you see my screen?
Yes. Yep. Okay.
Okay, so welcome to this meeting. My name is Mirek Nuňák and I'm a software engineer from Concrete team. And we are going to talk today about development of concrete templates and refactoring and some optimizations of concrete calculations. I would like to start with the refactoring and why it was necessary in the first place, because the design forms aren't with us for a long time, and I don't know, we are developing it, or guys are developing it for 2 years, I think, not much longer. And so why is the refactoring needed if it's still quite a new code? So, well, in the beginning, Concrete was a pilot, and it was meant that the PDEs will program the templates, and we as the software engineers will be responsible for the part of ESA and data preparation and other stuff, and they will write the code itself. But in the beginning, the language capabilities of design forms weren't so advanced as they are now, and guys didn't have any supervision, so they were writing the code according to their best, but there was no really lineup how the architecture of the templates should look like and anything like this. And the truth is that we as the software engineers didn't want to participate much on writing in some script language. So really they did their best, but the result was quite quite spaghetti code. I think it was a really nice example of it. And in that case, or as a result, it was really hard to maintain, really hard to know what is going on there, and it was really quite a mess. So this is what I want to start with. I will show you some of the templates before they were refactored, and on this example I want to show you what we did, what we think is quite a good approach, and how the code can be cleaner, and with the cleaner code you can make better optimizations. So I will show you example of check response, and it was almost in every template of our concrete check that you had some definition of colors which were used when template was drawing or in detailed output. And then you had some lot of lines of code when you were trying to get some coefficients from national annexes, where guys were trying to prepare materials for cross-section and everything else. And as a result, you can see there is a lot of code. I don't know, it was almost 200 lines for every template. That was really in every part of a template. And it was really hard to maintain this code and somehow get to know what is really going on there and what is necessary and what is not. Because the development was really a copy-paste. It was quite fast, but the results, when you want to maintain it, you really have to modify, for example, 50 templates if you wanted to do a change. And it didn't really work very well, because when we are looking at it, we saw that in some templates the code was different, and the changes that were made everywhere else wasn't propagated to some templates, so it was quite a mess. And this is the send template. So here we prepare some data from some model data, and then we transfer the parameters to the main calculation template for check response. So, and if you look to the check response, this is some other version where there is not, here. Then you have the validate input, so all the parameters were here validated, and on a few lines later you can see if not EOS extend CLC, it's the same code as in the previous template. Yeah. Again, definition of some colors, pens, materials, cross-section, and so on. And if you would open these concrete templates, you would find it almost in every last one of them. So this is the reason why we needed some refactoring. And I will show you some examples what we have achieved, what we improved. And you will see right away that it's quite a big difference. And it's really important to really define some parts of code that are used in many templates only in one place, so it can be easier to maintain. It can be more readable. So if you look at the code, everything is clear. This is also again the send template. As you can see, there are only few lines of code. It's these, I don't know, 10 lines that really are now necessary. And if you fill the input, it's quite limited, or it's the number of lines is really lower, and it's more clear that you really need for the calculation some setup values and not many materials or something else, because if we look now in the response template itself, the calculation template, you can see that the definition of materials and everything else was moved to the place where it really is necessary and where it should belong. So I will first start with the fonts. The definition of fonts was really in every template, so it was moved to a single template where it's an object. You have defined all the variables you need in the constructor, it's filled in, and you just call load external on the fonts and colors and get the font color object. Now you can use it. It's 2 lines of code. It's really easy to maintain. It's simple, and when you look at it, you really know what is going on there. And it's the same with the national annex clauses. We have created some objects. If I show here, it's for example clause with collapse. You have 2 methods, get alpha cc, get epsilon d, and everything else you have just some input parameters, and everything else, the calculation, the setting, or the picking up the right annex template is done here. So if you need gamma cc, you just something like that, you just call one method that gives some input parameters, and you don't have to handle the other stuff. And I think the biggest change we have made was for the creation of cross-section, where we introduced one CLC create CS, where we have 2 methods, create CS ULS and create CS SLS, and they handle all the data preparation of materials and everything else, and it's really in one place. So, and it's really simple. You just call create CS ULS, you put some input parameters, and you have a cross section, and everything that regards cross-section. That's materials, reinforcement, and some drawing and other stuff. It's encapsulated in this one object. So it's really easy to use. You can see here cross-section draw, header CSS drawing, and it draws you the shape of the cross-section with the reinforcement and everything. If I go back to the previous solution, usually all this code that I will select here was to create cross-section. Yeah, and the drawing it's somewhere further back, but it was also passing a lot of parameters from the cross-section, and it wasn't really nice. The other thing is that this cross-section object is, if I can show it to you here, it's really an object. It has some properties and everything what is needed for the work with the cross-section. Yeah, it has shapes, reinforcement, and other stuff. A lot of methods, so it's easy to use. And if you really want some to make a change, you do it on one place, and it's really important because you don't have to edit a lot of templates. So this was a part to the refactoring. If you have any question to this part, you can ask. And if not, I will continue with what we tried to do for some memory management and some optimizations. Because one problem what arises when we introduce this fonts and colors object was that the calculations themselves, mainly the CR concrete section, suddenly took a lot of memory, and the calculation was slow, and it couldn't handle such a large objects and large CRC files. Because I don't know if you are familiar with the CR concrete section, but it uses almost every concrete template that is here in an OpenCheck's directory. So as you can see, it's quite a lot of files, and if in every one you are creating this object, it's quite memory consuming. So this is when we used the functionality to store some objects to results. And for the fonts and colors, we have one method that gets you the object, and as you can see, it tests in the beginning if the results contains this object, and if not, it creates object, saves it to the results, and returns it. So this is created only once, and if I'll show you IO viewer, then you can see that here in member we have fonts and colors. It's defined only here, so we save here quite a lot of memory, and this is one way how we want to continue with the optimizations of the templates. Because when we will store these objects here, they will be there only once, and in case of some more complex objects like the cross-section I showed you, it really can save also time. And the cross-sections, we store them also to the results. For now we are storing them to combi, because we are not sure if we can really store it to the member itself. But in the following development we would try to move this really to the member if the member is prismatic, and this would also save some time of the calculation, and this is how we want to handle these optimizations. For example, these cross-sections are here saved with some unique ID. In this case, it's ID that is passed to the calculation templates. As you can see here, it's a SSID, and SSID should be unique for every type of cross-section. For example, the ULS cross-section has ID 1, the SLS cross-section has ID 2, and the different cross-sections, for example, with a different type of diagrams, or maybe even without reinforcement and other stuff, you should have unique ID, and this time they are created only once. And when the calculation or the check runs from the STIA complete section, these cross-sections are made on the place when they are needed, and they have unique IDs, and it's simple to see how many cross-sections you have and where have you created them. So I think this is something that is really quite an interesting stuff, quite an interesting feature, and in my opinion, this is something where in the calculations from STIA Engineer we can save some time. Because, for example, when we are creating the cross-sections, we are also somehow initializing the concrete toolbox, and if we do that only when it's really necessary, then the operations on both sides, on the design fronts and the concrete toolbox, can really save some time, because as we know from our measurements, the creation of cross-section is quite time-consuming on the side of concrete toolbox. So I think this is all I wanted to show you, and as the main message I wanted to pass to you is that really if you have some code that is used on more places, that it is really necessary to encapsulate it, for example, to some other CLC file, and keep it only in one place, because we are now refactoring the templates, and I think as guys can tell, it's really time consuming. It takes a lot of time to dig out the old code and replace it with the new one, and so this is the main thing. I think it's the most important thing I want you to take from this presentation. So if you have any question, feel free to ask.